Well, today's a big milestone in our integration development. We're going to introduce you to a concept called u-sub, which is an abbreviation for integration by substitution. And this is kind of going to be a catch-all method because when we were first teaching ourselves how to do derivatives, there was a plethora of rules. We had the power rule, and then we had all of our trig rules, and then after that, we had the product, and then shortly after product, we talked about the quotient, and then we had the monster rule with the chain rule, and then there was, beyond that, there was a variety, then we did the exponential rules and the natural log rules, and, on and on and on. Now, as far as integration goes, it's a much simpler process, okay? We've already introduced you to the power rule. We've taught you how to integrate x to the nth power. We've introduced you to a lot of the basic trig rules. Now, after that, we don't have a special rule for product and quotient and chain and everything. Basically, now we do u-sub. And u-sub is a method that's going to counteract all three of those derivative rules. So really, it's just one trick to memorize. And I shouldn't say trick, that doesn't do it justice. So let's go ahead and introduce you. So as we kind of set this up, I want you to think about how you derived f of g of x, okay? And you could instantly feel yourself doing chain rule, and you would say, well, we derived the outside, and we didn't touch the inner function, but then we finished by multiplying by the derivative of what was inside. So let's turn that one around on its head. What if we were integrating f prime of g of x times g prime? What if we were integrating that? Well, the antiderivative would have to be what? F of g of x plus c, wouldn't it? All right. So basically what we do is we've identified a composition of functions. Okay, look at the integral we were dealt with here. We had a composition right here. All right, let's label that. That's what we call a composition of functions. One is nestled inside of the other. And f prime was the outer, and more specifically, g was the inner function. And that's what we really want to focus on tonight, is identifying who the inner function is. Because once we identify the outer or the inner function, then we're golden and we're ready to go. I found this one and I just kind of Googled u-sub. This was the best image that popped up. And I like how it kind of succinctly identifies what we're doing. The key is to identify the inner function. And what's going to happen is we're going to let that inner function equal u. That's going to be our u. And then the derivative of u is going to be whatever's sitting on the outside. So that sounds very confusing, but that kind of gives you an image of how we're going to rewrite this according to our u-substitution method. So let's go ahead and we'll dive in. We'll go through the first one real slow, and then I'll kind of write out some steps for you to get in your notebook, and we'll just keep practicing on a variety of these. And I suspect by the time we get to the third or fourth one, you'll start to feel pretty good. So here it is. Here's our very first problem with u-substitution. Now, as a side note, everything we do tonight is going to be an indefinite integral. Just to kind of cut down on the amount of things we have to worry about. We're just going to worry about finding the antiderivatives. We're not going to be worried about plugging any bounds in. So here it is. And you'll notice if we covered up the integral sign and we just focused on the function that was dealt, how would you derive that function? Well, you definitely have to use some product rule, and in the midst of that product rule, we would have some chain rule kind of sprinkled in there. So anytime you see yourself using product or quotient or chain for the derivative, then that means we're going to be using u-sub for the integral. And what I've done here is I have identified an inner function right here. So first thing is to let u equal your inner function. And what we're going to do is, notice I didn't include the outer squared sign with that. It's just what was inside the parentheses. The next thing I want to do is I want to derive that with respect to x, because x is the independent variable here. So it's the derivative of u with respect to x equals 2x. And the next thing I'm going to do is I'm going to try to solve for dx. So I'll multiply dx to the other side. And then I'm going to divide by 2x, and so I have du divided by 2x equals dx. Notice, I'll repeat that. My goal, once I derived it, I was trying to solve for dx. Now the next thing I'm going to notice here is, you see the dx in the original? I'm going to substitute du over 2x in for that dx right there. And I'm going to substitute my u in for the x squared plus 1. So here's what it looks like now. What used to be the x squared plus 1 is now u, and it's being squared. I still have that 2x on the outside. And then where the dx used to be, I'm making a substitution of du over 2x. Now, do you see the beautiful cancellation we now have set up for ourselves? The 2x cancels the 2x. What am I really integrating? U squared with respect to u. At this point in the problem, we've got to make sure we've got all of the x's canceled right now. The entire integral has to be in terms of u. That's mandatory. And so the antiderivative of u squared is simply 1/3 u cubed. Don't forget your plus c because it's an indefinite integral. And then last but not least, I'm just going to rewrite it in terms of x. And my u is really x squared plus 1, and now it's being cubed. And so here's my final answer in terms of x. And the real easy thing to do here, ask yourself, how could I check this answer? Is there any way that I could check that answer? And just derive it. Just take the derivative, with a really nice basic chain rule, and the derivative would match the original expression, and that's how we know we did it right. So on this slide, I just want to kind of regroup and go over the steps that we did as the last problem. So you can kind of follow through the previous problem as we write out these general steps. First thing we're going to do for all of our u sub problems is we're going to let u equal whatever the inner function is. All right? And half the battle is just, whoops, I started to write the word battle. I should say inner function. All right. Half the battle is just identifying that there is a composition of functions. There's one nestled inside of another. And once you start to train your eye and identify the composition, you'll recognize who's the inner function. And that's what you're going to let u equal. Sometimes, picking the correct u, it's more of an art than a science. And it's just something that's developed over time. You'll build a better feel for it. But you just have to do, probably a couple hundred problems before you really develop that real strong gut feeling. Number 2, we're going to derive u with respect to who? X. Typically x. It might sometimes be a t or something, but typically it's with respect to x. Next thing we're going to do is we're going to solve for dx, and we're going to substitute that expression back into the original. At this moment, once you substitute back in, I want you to ask yourself, have I canceled all of the x's? Have we gotten rid of all the x's? Next thing we're going to do is now we're actually going to integrate. Now this time it's with respect to u because you have the whole problem in terms of u. You're going to basically find that antiderivative. And then the last thing you're going to do is you're going to rewrite, and this is the last thing we did on the last problem, you're going to rewrite the antiderivative in terms of x. Alright, so that's in a nutshell. Those are the 6 basic steps that we're going to follow for all of our u subs. Alright, here's our second problem. I'm going to sprinkle in a little bit of trig, 2 times the cosine of 5x. And here's where we just have to train our eye. You don't see any parentheses, and a lot of times if students don't see parentheses, they kind of panic and they don't identify the inner function. But there really is an invisible set of parentheses right there. And I would say 2 cosine is the outer, and therefore 5x is the inner. Especially if you ever feel yourself using the word of, and as you pronounce this, it's 2 times cosine of 5x. Of tells you who the inner function is. So let's go ahead and we'll let u equal the 5x. We're going to differentiate with respect to x. Now a lot of times what you're going to do is you'll see me instantly move the dx to the other side right away. And then we're going to solve for dx, so I've got du over 5 equals dx. And now we're going to make that substitution. This du over 5 is going in for dx. The u is going in for 5x. So we've got 2 times the cosine of u times du over 5. Now, we have gotten rid of all the x's, and that's the great thing. And what we're going to do is we're going to clean up these coefficients a little bit. I've got a coefficient of 2/5, and I'm just going to pull it out front and focus on integrating the cosine of u with respect to u. So what's the antiderivative of cosine? The antiderivative is positive sine plus c. And then the last thing is just to rewrite it so that we're in terms of x. And originally we said that u is a 5x. The parentheses are optional. And if we derived this expression, it would take us back to the original problem, confirming that we have done it correctly. I do have a lot of examples for you tonight. I think we just need to keep practicing and get as many as we can in our notebook tonight before we fall over with exhaustion. So we've got an x squared on the outside, and then I've got radical x cubed plus 1. Identify your inner function. I would say that the x cubed plus 1 is my inner function, and the derivative with respect to x Notice I did comment on the last one that I just instantly moved my dx to the other side. And now we're going to solve for dx. So du over 3x squared is equal to dx. And here's where we're going to substitute this expression in for dx. We'll substitute my u in for the x cubed plus 1. So I still have an x squared, I've got radical u, and then I've got du over 3x squared. Hopefully we get a, yes we do, we get a beautiful cancellation. The x squared cancels the x squared. What do we got left? What I'm going to do is I've got a coefficient of 1/3. Because that 3 was in the denominator, it's really a 1/3, and I'm going to rewrite my radical u as u to the 1/2 power, and now I'm ready to integrate. The antiderivative is, let's see, I got to add 1 to that exponent. That's going to give me 3/2. And then I've got to divide by 3/2, and which is equivalent to multiplying by 2/3. And then don't forget the 1/3 that was already there. So it's a 1/3 times 2/3, yada yada. And we'll just clean this bear up a little bit. Let's see, how about 2/9? My u was really x cubed plus 1 raised to the 3/2 power. You could rewrite this in radical form if you wanted to, and I'm going to leave my answer right there. Alright, keep on grinding here. Number 4, let's integrate. I've got a 6 in the numerator, and I've got radical 2x plus 1. You know what we should do? Let's make that a cubed root just to spice it up a little bit, shall we? Okay, so who's your inner function? My inner function is the quantity 2x plus 1. We're going to differentiate with respect to x. And again, solve for dx right there. So what am I going to do? I'm going to substitute this expression in for my dx. I'm going to substitute my u in for my 2x plus 1. We are ready to rock and roll. 6 over the cubed root of u times du over 2. What kind of coefficient do you want to pull out? Let's pull out a 3, shall we? 2 kills the 6, makes it a 3. And instead of saying 1 over the cubed root of u, let's just say u to the negative 1/3. Ladies and gentlemen, we're ready to do a little bit of calculus here. Now for the integration. So we bring down that 3. Oops, grab my pen. Okay, there's the 3. And the antiderivative, if I add 1, I'm really adding what? 3/3, right? So my new exponent is 2/3. And I've got to divide by 2/3 or multiply by 3/2. Get my plus c on there. Clean up my coefficient. I've got 9/2. I've got u to the 2/3. U was really the quantity 2x plus 1, so I rewrite it in terms of x plus c. Again, you could rewrite this expression in radical form, but I'm going to be content with leaving it just like that. Well, we are really chugging here. Let me go back and sprinkle in a little more sophisticated trig problem. Let's do sine squared of 3x times the cosine of 3x. And, you know, we could make an argument that 3x is the inner function, but I want you to think a little bit bigger than that. I want you to rewrite that first problem as the sine of 3x squared. I think that's going to clarify who the inner function is that we want. And there may be times where you pick an inner function, you pick a u statement, and you just eventually hit a dead end and you have to come back and restart and pick a different u. But I'm going to let u equal this rascal right here, the sine of 3x, whose derivative is going to be, so the derivative is going to be, let's see, 3, let's make sure I got my pen here. Alright, 3 cosine of 3x dx. Of course, we want to solve for dx there, so we get the 3 cosine of 3x over there. It's getting a little messy. I'll try to clean it up here for you. And a lot of times what's going to happen is you can anticipate the cancellation that's going to take place. So let's substitute this expression in for dx. Let's substitute the u in for the sine of 3x, and let's see if we're making any progress here. Cosine of 3x, and then you've got your du over 3 cosine of 3x. So like I said, you can anticipate a lot of times the cancellation that's going to take place. Make sure we killed all of the x's. And don't lose that coefficient. Don't lose that guy. That's the difference, you know. You just don't want that to be the deciding factor between your score of a 4 and a 5. Really hone in and lock in on those coefficients. So the antiderivative of u squared is going to be u cubed divided by 3. So my new coefficient is really 1/9. I'm going to rewrite it in terms of x. So we're going to say that you know, the sine of 3x is the quantity being cubed. And then, how else might you see it on a multiple choice exam? They might write it as sine cubed of 3x all over 9 plus c. A little more concise way of writing it, I guess. So be prepared for either of those writings at the end. All right, I think this is example number 6. I've lost track here a little bit. Let's go with the quantity 10x plus 5 times the quantity x squared plus x cubed. So like we said, we got a lot of problems here tonight, but it just means we need a lot of reps with this stuff. And who's your inner function? Go ahead and make that prediction right now. Hopefully you felt like x squared plus x was, because that's the quantity that's being raised to a power of 3. So in his derivative with respect to x is 2x plus 1, and just going to divide that quantity over 2x plus 1. Alright, here we go. Time to substitute in. So we got du over 2x plus 1 is going in for the dx. We've got our u going in for, whoops, my bad, into that quantity right there. So we still have the 10x plus 5. We've got u cubed, and then we've got du over 2x plus 1. So here we've hit a little bit of a road bump. What you notice is we don't have a clean cancellation like we normally do. But if you see this next trick, go ahead and factor out a GCF of 5. And that 10x is now a 2x, and that 5 is now a 1. Oh my goodness gracious, how convenient that became. So now we can make this cancellation. We've got a coefficient of 5. We're integrating u cubed with respect to u. Antiderivative is u to the 4th divided by 4. Therefore my coefficient is 5/4. And last but not least, let's rewrite our answer in terms of x. So we've got x squared plus x, all raised to the 4th plus c. There it is, ladies and gentlemen. Hey, let's go get one more. So here's our 7th example. Let's go ahead and integrate the tangent of 3x times secant squared of 3x. Now, comparing it, if you went back and looked at our 2 problems ago where we had sine squared times cosine, and we said, sine was our inner function because it was getting squared. You gotta be able to think ahead. I think the one trait that all great mathematicians have in common is the ability to kind of visualize 3 or 4 steps ahead of what their pencil's actually doing. And what you'll notice here is I need to let u equal tangent. And you're wondering, well, how did you know that? Well, what I'm doing is I'm visualizing ahead, and I notice that my derivative is what? 3 times who? Secant squared. Why is that a good thing? Well, what I'm doing is I'm anticipating a cancellation, right? I'm anticipating things canceling out. So by the time I solve for dx, I get the secant squared of 3x, and I really feel this problem setting itself up nicely. So the du over 3 secant squared is substituting for dx, the u's going in for tangent, and we're ready to rock and roll. So we got u times secant squared of 3x times du over 3 secant squared. And there may be times where you get to this stage of the problem and you're not able to cancel out the x's, and you got to go back and you got to pick a different u and retry it. But we got lucky here on this one because we were able to kind of anticipate what we wanted to cancel. Got a coefficient of 1/3 again. That seems to be a trend tonight. Coincidentally, I'm going to integrate my u, that's u squared, divided by 2, so my coefficient's 1/6 plus c. And last but not least, we'll just rewrite this so it's in terms of x. And we're going to go with the tangent of 3x squared plus c. So there it is, ladies and gentlemen. Big night, a lot of u-sub, a lot of practice, and we're going to really fight our way through some tomorrow until we build some confidence and become more efficient. So hope that works, and we'll see you tomorrow.